Welcome to the STEM Brothers podcast. I am Kwesi Vincent.
And I am Basir Vincent.
And we are the STEM Brothers. Well, welcome back, or hello for the first time. This is actually episode 2 of the STEM Brothers podcast. We are the podcast that discusses science, technology, engineering, and mathematics as it relates to your everyday life. STEM is a big buzzword out in the media. You hear a lot about it in terms of education, in terms of workforce needing more people with STEM backgrounds in science, math, technology, engineering, in order to fill jobs in those areas. And the reason why is because everything we touch involves some type of science, technology, engineering, and math. Those things go well beyond computers and laptops and iPhones. And last week, we did talk about a particular type of consumer electronics, and that's why this week we're going to make a little shift and talk about something else as it relates to STEM in your everyday life, science, technology, engineering, and mathematics in your everyday life. Talk about something completely different from consumer electronics. We're going to talk about food, and we'll get more into that a little bit later. But I really just wanted to, for those of you just now joining the podcast, as I said, we consider ourselves an education podcast. Hopefully you find it entertaining, but really what we want to do is serve as a gateway to educators. Maybe you're a science teacher, maybe you're a math teacher, and you're trying to find ways to relate the subjects that you're teaching or the lessons that you're teaching to some sort of practical application out in industry, so that your students are inspired to go out and solve problems or something along those lines. Or maybe you're an actual student and you're interested in getting into some type of field in science, technology, engineering, or math. Maybe you're a parent who wants to educate their child or encourage their child to go into the science, technology, engineering, and math fields. Whatever your background may be, even if you are a liberal arts English major, I still feel like this is a relevant podcast to your life, because that's what we're talking about. We're talking about your life and how it intersects with science, technology, engineering, and math on an everyday basis. So we hope that you use us as a resource. Obviously, in what should be about a 40-minute podcast, we can't give you everything. We're unable to make you a STEM professional in 45 minutes, despite our best efforts. But what we want to do is give you at least some initial information to spark your curiosity. And if you want more information, more detailed information, if you're, as I said, a teacher looking for a lesson plan that you can implement in your classroom, or if you're a parent looking for some exercises to give your child so that they learn more about careers in science, technology, engineering, and math, or if you're a student who's really interested in doing something in the STEM field and are looking for a way to get connected with possible mentors and just really get some coaching in that area, you can contact us. We are at stembros@gmail.com. That's stembros@gmail.com. So you can send us an email. We will have the website up very soon and functioning, and you can also contact us there. And pretty soon we'll have some social media and things like that for you guys to contact us, and we'll be off and running. So again, this is just our second episode. This is a labor of love. This is something that was born out of me and my brother's love for technology, but also frustration at the way the STEM subjects are taught in a lot of our institutions of education, as well as frustration over how career development is disseminated, or how career information is disseminated to us, especially in the STEM field. The STEM is wide open. There's so many different ways that you can have an impact in science, technology, engineering, and math. And all you need is a desire to make something better, to solve a problem, right? You don't like the shirt that you're wearing? Maybe you can find a way to make it better through different materials or some type of enhanced functionality to the shirt. You know, maybe you want a shirt that has a built-in wireless microphone for your cell phone, so you don't always have to keep losing your headphones, something like that. All these different things that are kind of all about your only limits are your imagination, and we can help you explore ways and find ways in which you can contribute to the STEM field, and also give you some coaching on how to get through the academic rigors of a STEM major if you decide to go that way. So anyway, with that said, let's move on. If you read the description of this show, you'll see that we're talking about something completely different from what our first episode covered. Our first episode, we talked about the smartwatch, and we'll go into last week's. We'll do a brief recap of last week's episode in a second. But what you'll see here is now we're going to talk about food, right? How science, technology, engineering, and math finds its way into your kitchen through the manufacturing of food, and we'll get into that in just a second. So, as I alluded to, just really quick, last week we talked about the smartwatch. There was a news article about Casio entering the smartwatch field, and based on that, we thought it was really apropos for our first episode to talk about this burgeoning technology, this technology that's going to, for the next 10 to 15 years, really see tremendous growth and create tremendous opportunity. So we spoke a lot about that. So, Basir, what did you think about last week's episode? What were some?
I thought it was very good. The one piece I wanted to add, I wanted to give a very interesting, I guess, nod to millennials, because I was reading another article about one of the applications that's going to be on the Apple Watch, and it's a Tinder app, and I just thought that was hilarious.
That is hilarious.
I feel like even elements such as dating, you find them bleeding into today's technology, and that's just one small way that it could be used.
Wow. So right on your wristwatch, you can
swipe left, man.
Well, that's tremendous. So, one more addendum that I had from last week. You had mentioned that your fiance uses a Fitbit, and when my wife actually heard that element of the podcast, she got on me for not mentioning that she uses a smartwatch and has been using one for the last year. She uses a Samsung smartwatch, and a lot of her usage entails really just an extension of her phone, being able to kind of not have her phone with her, but still be able to check her email, answer the occasional call, send the occasional text. So she's really into the smartwatch technology, but her usage of it is more as an extension of her mobile phone. So I thought that was pretty interesting, worth mentioning. So with that said, let's get into today's topic of the week. As I mentioned, we're going to talk about manufacturing, specifically manufacturing in the food industry. And what actually prompted this week's discussion was an article actually released by the White House, where the administration announced an additional 12 communities to receive federal support for local plans through Investing in Manufacturing Communities Partnership. And this is a program that's run by the U.S. Secretary or U.S. Department of Commerce, and the Secretary of Commerce is the head of that department. And the purpose of it is to forge strong manufacturing ecosystems in different areas throughout the United States. And manufacturing is on the rise. One of the stats that the article points out is that U.S. manufacturers, after a really rough period in the 90s, have added nearly 900,000 jobs since February of 2010. So the field is growing, and Basir, I know you'll talk more about some of the reasons that it's growing and things of that nature based on your experience. But another key note from the article is that 11 total federal agencies are funding the Investing in Manufacturing Communities Partnership, IMCP. Multiple federal agencies are funding this to the tune of $1 billion in economic development support. And all of this, again, is being run by the U.S. Department of Commerce, but as well as the Departments of Transportation, Agriculture, Labor, Small Business Administration, and as well as the Environmental Protection Agency are all participating in this. So what does this all mean? Well, a lot of money is coming into manufacturing. The U.S., the government, is investing in manufacturing as a way to grow the economy and provide opportunities for people in this country to do meaningful work and important work. One of the
what you see happening there is the government realizes that if they invest in manufacturing, that's jobs that will grow the economy of a specific area. And that's why you see such an important emphasis being put on that, because that is the source of income for an entire neighborhood. Could be one or two manufacturing facilities, or three or four, or in a lot of these cases, a whole neighborhood of connecting facilities.
Yeah. So the ecosystem that these manufacturing jobs create is pretty huge and impacts areas in the United States, has an extreme impact. When they arrive there, they create tremendous economic opportunity, and when they leave or close down, they create a lot of economic trouble. So very important. One of the elements that I zeroed in on in this particular article is the largest manufacturing industry in California. But point being, I bring this up because California is a huge state. Obviously, they're investing lots of money in their manufacturing industry, and particularly food. And that got me thinking about we all eat, right? Eating is something that's going to be here for a long time. And it got me thinking about you, Basir, and what you do for many years working in the factories of Nestle Purina. It really got me thinking about how important food manufacturing is, and how little most of us actually know about what happens behind the scenes. Most of us get, for those of us who live an active lifestyle, you get a protein bar or something like that. Most of us get that, open that up, and don't even think about all that had to go in to making that protein bar. And just think about how that protein bar that's on the shelf at the supermarket or what have you is the exact same protein bar that's in Pennsylvania where we live. It's the same protein bar that's all the way out in California in terms of consistency and size and all that kind of stuff. So it's actually a pretty remarkable thing when you think about it, the whole process of food manufacturing. So I wanted to explore that. I wanted to have our conversation this week revolve around food manufacturing and the opportunities involved with it, and a little bit of background in food manufacturing based on your experience. And let's give the listeners some insight into how things get from raw crops out in the field, or milk from cows and different things, and become yogurt or whatever else, whatever other foods we buy from the supermarket. So let's get into a discussion about food manufacturing. So Talk about your experience at Nestle Purina, and then go into some more detail there.
Okay. Well, first, you nailed it right on the head. Just listen to that. 11 different federal agencies are investing. That just shows you how many different areas food manufacturing touches, and you can't even imagine. So we'll start at the farm. As a farmer, you're looking for a company that could use a lot of whatever ingredient you have. So that's going to keep your farmer in business. So now we're talking about raw materials. You want to get your basic ingredients. You want to get your meats, your grains, your vitamins. That is one element of the process I don't even have time to go into, and that's its own business itself. So as a company or as someone who is working at that, you are trying to source all those ingredients and source them at the quality and quantity and consistency that you can make, say, you mentioned a energy bar of some sort, and you can make millions of those, and it's made of the same ingredients or very similar quality ingredients. So now you have your ingredient stream, and just that, the quality of the ingredients will introduce your first major entry into your STEM at a factory, and that's your quality, your ingredient verification, identification, and selection. This dives into chemistry, it dives into food science. There are many aspects of ingredients, what an ingredient should be, and how do you test for that ingredient. Someone has to design that test. Someone has to know enough about a specific type of grain to recognize that they have to be able to test to make sure that this particular product has a certain amount of protein in it. Therefore, if you're reading the back nutritional label, all those numbers are guarantees. If you buy an energy bar and it says it has 20 grams of protein, the manufacturer has to make sure they have enough ingredients built into that bar to equal 20 grams of protein. And that protein might come from different sources. So the quality of your ingredients is the first case. So it's the quality of the ingredients and the testing of the ingredients. That opens up a field of chemical engineers, that opens up a field of quality assurance testers, that opens up a huge connection to government organizations such as the USDA, which allow you to source food and create food. So that's just the beginning of the process. Once you receive those ingredients, the first step is then processing it. So now you have to have equipment to be able to move those ingredients. So one element that we don't touch in this podcast, I just have to mention because we are talking about manufacturing, is the logistics of getting an ingredient from one place to another. And that's a big can of worms that I don't even want to open. So once you actually get the ingredient to your facility, you have to be able to move and store these ingredients. So if you want to think about, one, the ability to move and store these ingredients, you're going to need some type of storage container, and you're going to need some type of mechanism to move that ingredient. So what does that mean? You need a pump. You need a elevator. You need something that's going to run mechanically to transfer a base ingredient into some type of storage bin. So you need someone to design a storage bin. You need the storage bin potentially to be refrigerated, non-refrigerated. It could need to be stored at room temperature. It could be an ingredient that needs heating. And that opens up a whole another world just in this very beginning process. Now you're talking about, okay, who's designing the pump that's moving this liquid from a tanker into your building, or raw grains into some type of silo. That all has to be designed and programmed to effectively move the ingredients and isolate those ingredients, because they might not want to be mixed at this point. So you need some type of ingredient transfer and storage. All of that equipment design, and maintenance is all touched on by people who work in the STEM fields. Now, once you get into the manufacturing facility, you have to now process these. So there's some type of mixing or cooking process. And that, just like a kitchen has a lot of chemistry involved in it, you're talking about breaking down ingredients where at a chemical level, you're changing the properties. If you heat up a certain type of ingredient beyond, say, 200 degrees, that's going to have very different attributes and traits than something that might be room temperature. It's going to affect the way that that ingredient mixes with other ingredients. It's going to affect the way that that ingredient that ingredient flows through the equipment that you have designed for that particular ingredient at a particular temperature. Once you process that ingredient, I'm taking a huge leap here because the processing part of a manufacturing facility is, once again, that could be its own podcast. There is a whole nother level of engineering and execution and science and chemistry. All of these skills people are using to perfect these processes and perfect them in an effective manner. So once you're done processing, another big element of the STEM field becomes your packing of a particular product. So let's go back to a power bar. You are purchasing a power bar in a wrapped container. There are packaging engineers, and I want to give a highlight. There are a lot of good schools that have specific packaging engineering programs. Right. That's a field that I didn't know about until I got into manufacturing.
That's right. Yeah.
Or some schools and colleges that's what they excel in, packaging engineering. And if you go to a grocery store and imagine it from a packaging engineer's perspective, you have glass bottles, you have cans, you have tubs, you have packages, you have plastics, you have potato chip bags. There are a whole plethora of carrying devices that just contain the things that we eat. If you drink from a bottle, something had to pour into that bottle and seal that bottle, wrap that bottle with a label, and then somehow mark it with an expiration date. The expiration date, that's one element of a manufacturing process that I always love to show off. When I go through a store, you can look and you can see that there's a specific piece of equipment that codes every single bottle label that you're going to buy, and it's going to give some type of expiration date. That's a piece of equipment that was designed and needs to be maintained by someone who's technologically skilled and savvy. Once you get to the packaging portion, now you're talking about shipping, and then finally we get to see it on a shelf where we purchase it. Everything that I just said, and I gave a very nutshell explanation of the manufacturing process and how different elements can be affected, there are teams of people who make sure that, one, they come up with the outline of that process, then two, they execute that process. So there's another set of people who have to execute that process. And that really is what manufacturing is the execution of that process from raw ingredient to on-the-shelf purchasing. And then there's a whole other set of people who work on looking at that process and perfecting it. And you need to have what you called literacy of the technology to be able to perfect that process and work on doing all of that more efficiently for a cheaper cost and be able to get more product out. In a nutshell, that is how STEM and manufacturing are tied together, and that is the world that is manufacturing in a very brief overview.
Right. And so that breakdown, there was at least there were so many different little specialties and offshoots of possible STEM careers within everything that you just said. Because, correct me if I'm wrong, but you did say, and we do know that you have engineers who strictly are just masters of packaging, the science behind packaging.
Yes.
And what people have to realize is that packaging is a science. It is important, right? Because you have to know how to package something so that air won't get in there, or just the amount of air, the right amount of air gets in there. Because what happens when when something's exposed to air that can spoil, that's perishable.
Yes.
Right. You know what happens, right? So packaging engineers need to understand what kind of material they can use to make the package, how the actual form and function of that package, so that it can avoid moisture getting in or air getting in or whatever the case. A variety of different concerns depending on what kind of food item we're talking about. Is that correct?
That's absolutely correct. And the evolution of that process has been amazing. We can look at one of the older technologies, and I can dive into that, is the can.
Mm-hmm.
A can for a processing factory has to be specifically designed, and you have a variety of cans. What you might get your cranberry sauce in, or what you might get a variety of product. You have to design it so, yes, it has a shelf life of a very specific shelf life. So that means air can't get into that container. It has to be sealed properly. It has to be able to survive shipping all across the world without breaking. And it has to be labeled correctly. That label has to be on it. It has to read the correct thing. It has to be able to be read and identified. That process of selecting that type of container and perfecting that type of container is a whole industry. That in itself is just a subset, and there are countless advances that are constantly being made. There are new containers being created and tried, and there are old containers that we still use cans very much in today's industry. A lot of times they've transferred from doing a 3-part can where you have the body, a bottom seal, and a top seal, but that creates a lot of failure points. So some companies will design a 2-part can, and you can tell the difference. I don't know, a very personal story. I don't know if you noticed the difference of the cranberry sauce our mother used to be a 3-part can. So you'd be able to open it from the top or the bottom just the same.
Right.
Now, because that creates an extra failure point, it's now a 2-part can. So you can only open it from the top with a can opener. That's such a subtle difference, but that change probably cost or saved a company millions of dollars in steel and aluminum shavings from not having to cut a can and being able to use one piece instead of 3. Not having to seal the bottom of the can and being able to just have one seal point. That decreases the amount of checks that you have.
Yes.
It's all about efficiency in the manufacturing process, and that was a huge project that somebody embarked upon and then changed an entire manufacturing process just to make that casing, that tin can, a little bit different. But it's affected everything.
And subsequently probably allowed the company to produce at a more efficient rate, thereby, probably producing more supply of the cranberry sauce and making it more readily available for the populace. And I'm sure those types of improvements in the can lead to less issues with contamination and better safety, as you say, for the containment of the food item inside the can itself. And I guess what I'm getting at is that kind of advancement, doing that kind of work, has a lot of societal value. What are your thoughts on? What are your thoughts on the societal importance of people who do this kind of work?
Absolutely. In order to make things affordable for everyone, so that I can go to a store and I can purchase something that I know is going to last. The raw ingredients, you can only do so much to change those prices. They are going to fluctuate. If you control the process, you can make things more available to a wider range of people. The ability to manufacture and distribute food at such a large rate contributes to our society's ability to advance, because it allows people to spend less time on certain elements that they may work on and put that effort into something else. Manufacturing will allow us to take a process that would take one person a full day to do, and you can multiply the output and allow one person to feed a lot more people in a community and essentially the world than you could without that technology.
Absolutely. Let's, as we are coming towards the end of our time, why don't we talk about, similar to what we did last week, why don't we talk about some of the opportunities career-wise in the food manufacturing space, and then let's also talk about some possible entrepreneurial opportunities that may exist. I think you alluded to some of it. I mean, we've covered the packaging thing pretty well. What are $1 billion being invested into manufacturing across the country? What kind of opportunities are being created there?
All right. And one of the big ones I always love to touch on, and I think it's important for us to mention during this podcast, because we mentioned STEM, and both of us have 4-year engineering degrees. But what we've seen after being in the working world for a while is that is not the only opportunity. A lot of the money is going into training various elements that you need for manufacturing. There are tons of 2-year technical degrees or smaller technical degrees that would make you an invaluable and very well paid asset to any of these manufacturing companies. PLC technicians, electricians, mechanics, these are the very building blocks of a factory from a technical aspect. So I don't mean to discredit, and I do want to highlight, in a manufacturing community, you are going to have a lot of jobs that you might need, and you might just need a high school or equivalent degree. But more and more, you're needing highly technical people who are technology literate, who can look at a piece of equipment and break that piece of equipment down and be able to maintain it, be able to tweak it. Those are the degrees that a lot of these companies are really looking for. And that's an element that gets overlooked a lot of times when you think about opportunities or business opportunities. There are tons of pieces of equipment in any manufacturing facility that you don't get direct training on, but the basic concepts of understanding how a programmable logic controller. So I apologize before. I think I used the acronym PLC, programmable logic controller. That's what controls it. That is the brains that tells a robotic arm where to grab and where to drop a bag. That is what gives the information that a flow meter picks up for how much of an ingredient has flowed through a specific pipe and lets you know how much product you're delivering. There are tons of opportunities with that technical discipline in the background. And there are internship opportunities, full-time opportunities, and lots of educational opportunities that a lot of these governmental dollars and grants are going to trying to teach people. You're going to see a gap in the jobs that are available and the people that are filling those jobs in particular communities. And a large portion of the time, it's the technical training which will help fill that gap. That will mean the difference between job security and getting lucky and finding a job. If you're able to identify what those smaller technical degrees are that are going to get you that advantage, that's what people hopefully listening to this podcast, that's a whole world that I want people to look at. Yes, you might not have the money or the time to dedicate to a 4-year degree, but a focused 2-year degree in a technical discipline will get you the understanding and the ability to look at a technical system and break it down that'll make you valuable to one of these manufacturing facilities.
Absolutely. That's a great breakdown. The 2-year degree is something that is a lot of times overlooked, but is an incredibly vital part of the STEM, the science, technology, engineering, and mathematics ecosystem. The technicians that actually are hands-on with the machines. You have the 4-year degree people who may design the system and things like that, but that system needs to be maintained and operated by people with technical know-how. And the 2-year degree is a great gateway to those types of careers. And with the president's push for community college education being free throughout the country, The community colleges are the places where most of these 2-year degrees, where you can go and earn most of these 2-year degrees. So there's a tremendous the way things are trending. There's tremendous opportunities for people to go pursue 2-year degrees, get those degrees, and get some, and then have there be a nice market for people with those skill sets, and some good options career wise for individuals with those 2-year degrees. Really quickly, because I know we're coming at the end of our time. Again, so we talked about the 2-year degree. What are some things that I'll start off. I know from an entrepreneurial standpoint, working at McMaster-Carr, a lot of the customers that we serve are these small machine shops that will do custom jobs for different food processors. A lot of times when a food processing plant will have different, just as you talked about, they're just different elements. They may need to separate this raw material from this material. They may need to add water to this process or dehydrate this. A lot of times there certainly, for a lot of well-known processes, there are definitely large-scale industry standard machines, but there are other processes especially for smaller niche those food manufacturers, food people who do something very specific and unique to the industry. They may have a food processing. They may have a need for a certain process that requires a specialized machine, a specialized piece of equipment, something built, custom made, right? Custom made for that particular factory setting. So all that to say is there are a lot of mechanical engineering firms, electrical engineering firms, and what we generally call machine shops, businesses that build machines of some type. There are a lot of those types of companies. These are 5 to 20 employee firms that are actually building machines for large and small food manufacturers. And that's a lot of the business we see at McMaster-Carr. A lot of those folks who buy our engineering supplies are companies like that. So that's one aspect of how entrepreneurship fits into this whole ecosystem, designing and building equipment for the food manufacturer to execute a particular food processing function. What are some other entrepreneurial things that you see from your standpoint?
Well, absolutely. What you just said, there are tons of elements that take part in the manufacturing factory. So the article mentioned Wisconsin, and one of the areas that people don't really know about is an area called Waukesha, where it's actually a smaller company, and they created a pump manufacturer. That's one of the pumps that we use in a lot of our facilities. Something as little as that, you don't think of, there's a whole facility that's designed around making pumps. There are other contracting type opportunities that are always involved when you're in and around a manufacturing facility. Mm-hmm. If you have a group of people who are technically savvy and they can do a specific task very well, you can get your opportunity from a manufacturing factory and offer your product, offer your service, whether that be anything from something as highly technical as a pump design or something as highly simple as our factory just changed the cleaning company that we use, and we went to a smaller cleaning company because they are a little bit more, they're able to be a little bit more personable. They're able to service us a little more. So there's always going to be opportunities when you're looking at a manufacturing factory. You can also do some independent consulting if you get really skilled in a discipline such as process improvement. One of the items that you'll see a lot of out there, and this is very tied closely to what I do because I'm actually internally tasked for this type of work. But from an entrepreneurial standpoint, getting your Six Sigma certification and learning how to come into a system of any type and be able to make process improvements on it. So step one would be being able to be at least technically savvy to understand that aspect, but then being able to apply it and being able to do that successfully and repeatedly. You can create a whole separate contracting or independent branch just around that aspect of a manufacturing factory.
Absolutely. Well, that was great. There's so many other opportunities, just a bunch popped into my mind. But as I mentioned at the beginning of the podcast, this is not designed to be a comprehensive review of any one industry. We're really here just to kind of get the wheels turning, whet your appetite to learn more about the particular topic in science, technology, engineering, and mathematics that we cover. And we hope that we made it relatable to your life, and we hope that you're actually inspired or curious to go out and learn more about how you can contribute to this particular field, whether it be this week we talked about food manufacturing, last week we talked about the smartwatch, next week we'll cover something else that impacts your everyday life, something that you see, interact with every day, and the opportunities to become to have influence in that space, and not just a passive consumer, but be an actual active contributor to that space if that's what you would like to do. So, Basir, anything else from you in closing?
Absolutely. Just really, I barely scratched the surface. There are elements that I skipped over. I could have talked about any of the sections in full detail, so I definitely did not do any of them the full justice. So I hope that we all get a chance to touch base with them. I hope that people might have questions in the future, because the opportunities involved in manufacturing are so vast and so big. I'm still discovering new ones on a weekly basis, still looking at opportunities that just pop up, and it's like, and I'm always amazed at how many different paths that you can follow if you just have this basic understanding. And that's really the idea that I hope we get across, that there are so many different paths.
So many. All you need is the curiosity and the imagination, and hopefully we'll help inspire that in you. And if you need more information, or would like more information on what we've talked about here, let me give you the email again. It's simply STEM Bros, STEM, so Sam, Tom, Edward, Mary, BROS @gmail.com. You can send us an email. Again, we have a website coming. We have all the social media and all that kind of stuff coming. But if you find this podcast before all that stuff comes up, just simply send us an email at stembros, STEMBROS @gmail.com. And we can come to your school, do a workshop. We can do one-on-one coaching. We can do a lot of stuff. So again, this is just something to get you started, kind of introduce you to a particular area of STEM, get you curious, and from here, hopefully we have a conversation directly with you, or you can follow us on our various social media platforms, websites, all those things that will be coming in the future. But stay tuned. Want to thank you for joining us this week on another STEM Brothers podcast, and we will be back next week with a new topic, a new discussion, and hopefully we'll have a third person joining us that we will interview on the particular topic of the week. Not 100% sure, still working on it, but even if we don't, me and my brother Basir, we will still have good information for you, have a good conversation that hopefully you can learn from and take some action with. Thanks very much, and we will see you again soon. We are gone.
Bye.